Now, let us see the welfare properties of general economic equilibrium. Let us define, first of all, the concept of a Pareto optimum. We need the concept of an allocation, but an allocation is nothing but a possible distribution of the available quantities of goods between our two consumers. In other terms, an allocation is any point in the Azure box. Any point in the Azure box, like this X, say, has obviously 4 coordinates. 2 coordinates for the first subject and 2 coordinates for the second subject. If you sum the first coordinate of the first subject and the first coordinate of the second subject, you obtain simply the length of the basis of the Azure box. Similarly, if you sum the second coordinate for subject 1 and the second coordinate for subject 2, you obtain another time the length of the 8. And so this point represents a possible distribution of available goods between our two consumers. Now, as usual, let us construct the indifference curves which passes by X. This is for the subject 1, this is for the subject 2. Note that if you move from the allocation X to this allocation, say X prime, both consumers will posit on a higher indifference curve. In other terms, their utilities, if utility exists, are greater than in X. In other terms, given the total available quantities of goods, by means of this redistribution, this passage from the original X to this X prime, you have succeeded in increasing both the utilities. The allocation X is not efficient. An efficient allocation is one with respect to which is not possible to increase both the utilities by means of a redistribution, or also by increasing one utility by giving the other utility constant. Definition of a Pareto optimum. This is an allocation X which guarantees to the first consumer the bundle X1 and to the second consumer the bundle X2. Note that these X1 and X2 are vectors, 2-component vectors. So X is a 4-component vector. However, this allocation X, which guarantees etc., 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 is a Pareto optimum if there not exist negative definition. Another allocation X prime with these components such that let us use the preferences. X prime H is preferably indifferent to XH for every H which ranges from 1 to 2, and there exists a K such that X prime K is strictly preferred to XK. This is the so-called strong Pareto optimum, because there is also a weak Pareto optimum, as we shall see afterwards. But let us repeat. A particular location X constitutes a Pareto optimum in this consumption economy if there not exist another allocation X prime such that for every subject the bound X prime H is preferably indifferent to XH, and there exists at least one subject K such that there is a strict preference. In other terms, it is not possible to ameliorate the condition of some subject K without worsening the condition of some other subject in the economy. This is the strong Pareto optimum, because there is also the weak Pareto optimum. In order to have a weak Pareto optimum, it is sufficient that there not exist an X prime such that for every subject there is a strict preference. But however, let us remain with the strong Pareto optimum as defined here. Now, we can, as usual, represent Pareto optima graphically. Clearly, Pareto optimum is an allocation like this X, such that the allocation which better ameliorates the condition of subject 1 has a void intersection with the set of allocation with better the condition of subject 2. You remember, under suitable hypothesis of differentiability, you have that in a Pareto optimum, the indifferent schools must be tangent, equality of marginal rate of substitution, and so on. You remember surely that there is more than one Pareto optimum. For example, also this point, it is a Pareto optimum, also this point, and so on. There are many Pareto optima. The set of all Pareto optima, which is this path, dotted path, is the so-called Pareto set. The set of allocation which are Pareto optima. Is it clear? Note that in order to define Pareto optima, is not relevant to introduce the individual initial endowment. It is sufficient to know the total initial endowment of economy, both of good 1 and good 2. But now, let us return to our pure exchange economy, and let us introduce the initial endowment, the point which represents the individual initial endowments. Here. This is the Pareto set. But if you consider a pure exchange economy, not all the points on the Pareto set are relevant, but only those of this subset. which has the name of contract curve. Why? But clearly, if you exchange on the market, the optimal bundle gives you a utility which must be greater or equal to that of an initial endowment. If the optimal bundle had a utility which is lesser than the utility of initial endowment, you cannot choose that bundle. You would remain in the initial endowment itself in order to maximize utility. So, the point which is relevant for us are also the points in which, like this X, every individual is better than in the initial endowment, or his utility is equal to that of the initial endowment. This is the contract curve, the term that was introduced by the English economist Francis Edgeworth, which stated that after the exchange, the allocation we obtain is exactly on the contract curve. This is substantially a premonition of Pareto result. According to which the equilibrium allocation in a pure competition economy must be a Pareto optimum. This theorem can be easily proved also in this elementary case. However, in the following lessons I will give you a much more general demonstration of this fundamental result. Let us have another interval.